All right, let's talk about building AI that can actually think. We're diving into LangGraph, which is honestly a total game changer for creating those complex, agentic systems that can reason and adapt on the fly.
So here's the plan. We'll start with why simple chains just don't cut it anymore. Then, we'll get into the heart of it, what state graphs are, and break down their anatomy. After that, we'll see how they give us intelligent control flow, and finally, put it all together to build a real agentic system.
So let's get right into it. If you've ever been building with something like LangChain and hit a wall because of its linear, straight-line nature, yeah, you're definitely not alone. It begs the question, right? How do we move beyond these simple workflows to build something truly intelligent?
Think about it this way. On one hand, you've got a basic chatbot that just answers questions from a policy document. Super linear, super predictable. On the other hand, you have a deep research assistant that has to browse the web, figure out what's good information, what's not, and then synthesize it all. The first one, that's classic LangChain territory. But for that complex, looping, stateful workflow, well, that's where you need LangGraph.
You know, the real threshold, the thing that makes you jump from LangChain to LangGraph, it all comes down to this one core component, the state graph. This is the absolute key to unlocking all that complexity, and it's really where LangGraph just completely shines.
Okay, so that brings us to the main event. What is a state graph, really? How does this thing actually form the foundation for the kind of cyclical, stateful computation we're talking about?
So at its core, a state graph is basically a computational graph where all the nodes, all the steps, share a persistent state. It's not just a simple flowchart. Think of it more like a dynamic blueprint for your application, but one that has a shared memory. This allows for these really complex, cyclical workflows where the system actually remembers what it's done. And this is a pretty big deal because it lets you shift your focus. Instead of getting bogged down in the nitty-gritty implementation of orchestration, you get to think at a higher level. You're focusing on the architecture, on the actual problem solving, and LangGraph handles the how of running and coordinating everything. It's a much more powerful way to build.
All right, to really build with LangGraph, we've got to understand its core components. Let's deconstruct the anatomy of a graph and look at the three big pieces: state, nodes, and edges.
First up, we have nodes. A node is just an individual unit of computation. This could be pretty much anything you want it to be: a simple Python function, a callout to an LLM, or even a tool invocation like a web search. Each node is like a specialist on your team, responsible for one specific task.
Next, you have edges. Now, edges are what connect your nodes together. They define the flow of execution. But here's the cool part. Edges can be conditional. This is what gives the graph its intelligence. They're not just dumb pipes. They're decision points that direct the workflow down different paths based on what's happening in the state.
And finally, the most important part, in my opinion, is the state. This is the shared memory object that gets passed between all the nodes in the graph. Every node can read from it and write to it. It's the persistent memory that allows the whole system to have context and build upon previous steps.
Okay, let's look at a real example for that research assistant we were talking about. Here, we can define the structure of our state using a type dict. As you can see, it tracks everything: the original topic, the list of URLs we need to check, the content of the current URL we're looking at, its score, and of course, the list of facts we've gathered. This is the agent's brain, basically. And this workflow is a perfect illustration of how it all comes together. Each of these steps, searching for sources, scraping the content, evaluating it, branching based on that evaluation, extracting facts, and then finally writing the report, each one is a node in our graph. And as the process moves from one node to the next, that state object we just saw is constantly being updated.
All right, so we've got the building blocks: nodes, edges, and state. Now for the really cool part. Let's see how LangGraph uses these to create intelligent control flow, allowing our agent to have genuinely adaptive behavior.
So, a critical decision point for our research agent is figuring out if a source is any good, right? Is this source trustworthy? How does the graph actually handle a question like that?
Well, it uses a conditional edge. It's actually pretty simple. Based on that current score we have in our shared state, the graph makes a decision. If the score is greater than 75, great. We'll take the yes path and route to the extract facts node. But if it's 75 or less, nope. We take the no path, discard that source, and move on to the next URL. This creates these dynamic, adaptive pathways.
And LangGraph is also fantastic at creating loops for iteration. Think about it. What if your first search just isn't very good? You don't want to proceed with bad results. So you can build a loop.
You execute a search, you evaluate the quality, and then a special conditional function checks the state. It might ask, should we continue? If the quality is too low, it says yes, maybe refines the search query, and loops right back to the search step. If the results are good enough, it says no, and we finally exit the loop to generate the report.
Okay, let's put this all together. We've seen the individual pieces, but now let's zoom out and see how this enables us to build a fully functioning agentic system.
And the difference is just night and day. Look at this comparison. With a traditional sequential chain, every step is basically independent. It has no memory. If you greet Alice, the next prompt has already forgotten her name. But with a stateful graph in LangGraph, that state is preserved. It remembers Alice, so the farewell prompt can actually say, "Goodbye, Alice." It's the difference between amnesia and having a full memory of the entire interaction. So, when you pull all these capabilities together, that persistent state management, the modular node-based computation, the smart decision-making from conditional edges, the power of loops for iteration, and even seamless tool integration, where a web search is just another node, what you get is something incredible. You can build systems that don't just react, they can adapt, they can refine their work, and they can accumulate knowledge over time. It's a whole different level.
Look, LangGraph really moves us beyond simple automation and into true agentic workflow creation. It's not just another library. It's a new way of thinking about building these systems. So the only question left really is, what kind of adaptive, intelligent system are you going to build?